All right, one way you can find GCD and LCM is by what's called the intersection of sets method. So we're going to look for where these sets have an intersection. So for the GCD, the greatest common divisor, you're going to list out all of the divisors of each number and then look for the intersection of the two sets. The GCD will be the largest divisor, right? The greatest common divisor, and the intersection is what they have in common, what the two sets have in common. But this is going to require us to list out all of the divisors of each of these numbers, so I hope the numbers aren't very big. So what we're asked is to find the GCD of 20 and 42. That's what that says. So I'm going to list out all of the divisors of 20 and then all the divisors of 42, and let's see if we have any overlap. So for 20, lots of numbers divide into 20. I'm going to try to list them in order. We have 1 and 2 and 4 and 5 and 10 and 20. So sometimes you can kind of like ping pong back and forth here, like 1 and 20, 2 and 10, 4 and 5. You can kind of work your way into the middle. For 42, there's a lot more divisors than we have for 20. So there's 1 and 2 and 3. I know 3 goes in there because if you add 2 and 4, you get 6. 6 and 7 divide into 42, and 14 and 21. And then of course 42. So 1 and 42, 2 and 21, 3 and 14, 6 and 7. But this is not an easy list to come up with. And like I said, if these numbers were even bigger, this becomes very inefficient. So this method works, but it's not my favorite. Now we're trying to find all the ones they have in common. So they have a 1 in common, a 2, and that's it. That's all the ones they have in common. So we want the biggest one. So the largest divisor both sets have in common is 2. So the greatest common divisor is 2. Your final answer is just a number. So that's how you find the greatest common divisor. You have to list out all the divisors, and you look for the intersection of the sets. You pick the biggest one. So you can use a similar method to find LCM. It's just you won't be listing the divisors, you'll be listing the multiples, because this is the least common multiple. So we're looking for the smallest multiple that they have in common. So you're going to list the multiples of each number, then look for the intersection, and then you want the smallest multiple that they have in common. It's a little easier to write out multiples. So this says find the LCM of 12 and 60. So I'm going to write out some multiples of 12, like 12, 24, 36, 48, 60, 72. The problem is I don't really know where to stop. Okay, 84, 96, you know, like maybe I'm done, maybe I'm not, I don't know. Let's look at the multiples of 60. The multiples of 60 would be 60, you always start with the number itself, 120, 180, 240, etc., right? So you got to have at least one in common. Let me go just a few more on this one just because I want to show you. Just put a few more multiples out there. Okay, you're looking for the ones that are common. The first one that they have in common is 60. But I do want you to notice they also have 120 in common. They have others in common. But we're looking for the smallest one. So the smallest one is actually going to be 60. The first multiple they both have in common is 60. So the LCM is going to be 60. And that's how you do intersection of sets for GCD and LCM.